Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm all right. Thank you. How are you?
Very good.
Good.
So, Amy, how was your school today?
Good. Yeah. But we covered modulus functions and solving modulus equations. It's getting quite tricky. So we started off like nice and easy, and then we were doing like modulus functions equals another modulus. So we couldn't use that simple like piecewise function without actually drawing the graphs. Otherwise, you won't know which of the x values to use. But I did actually get a bit confused with in terms of gradient. So I know if it's like 2x and then x, obviously one is steeper than the other, then you can know where it would intersect. But
Right.
with some quadratics, I was finding a little bit tricky on knowing if it intersects on this part, the one that gets flipped from the axis, so it looks like a W. So yeah, some questions like that. So I thought if it would be all right if we could go through some just to clarify.
Yeah, sure. Actually, you're talking about a very interesting topic. We are looking into not just one modulus function, but we are looking into two modulus functions at one time. And we are
Right.
also looking at, as you said, about the linear function. How does a modulus and a linear function combination works out? So
Yeah.
we will be solving equations with modulus on one side, linear on the other side, or modulus and modulus. And another very interesting twist could be if we could involve quadratic equations and
Oh.
nested modulus function. That will be amazing, actually. So,
Oh,
yeah,
within a modulus. Oh,
within a
yeah. No, I've
modulus,
never seen
another
that before.
modulus function, right?
Yeah.
So, I guess that'd be very good. So, I'd like you to first share what you have, and then I will add some of my questions and hope to make it an interesting class today.
All right. Okay. Yeah, so I've just got some random ones. So the main one was the two that I shared with you, which was the modulus of x squared minus 8x plus 12 equaling the modulus of x plus 4. Then there was also another question, and then I thought we could just randomly do ones from my textbook.
Sure, sure.
So I feel like these ones are just more of the graphical side. So I think question 16 looks fairly straightforward.
Yeah.
I don't know. So if you see any that would be like really
Well,
good to understand.
okay, so we can take up any. Let's say question 20. What does it say?
Okay. So it says sketch the graph of y equals the absolute function of x minus 2a, where a is a positive constant, and show the coordinates of the point where the graph meets the axes. Part B, using algebra, solve for x in terms of a, where the absolute function of x minus 2a equals a third x. And then C would just be on a separate diagram, sketch the graph of y equals a minus x, absolute function of x minus 2a.
Okay, so 20a, sketch the graph of y equals to absolute value of x minus 2a, where a is a positive constant. So you could choose any value of a. The only thing is when you say it is a positive constant, that means the absolute function has been translated 2a units to the right side. That's what they're trying to say, right? So that is simple. You can have let me just sketch one. Let's make a. So if my absolute function is like this, let's say like this. So this is, let us say, absolute value of x, correct? Now, if I want to sketch absolute value of x minus 2a, it means it is moving 2a units. Let's say this is a. In that case, that'll be 2a, correct?
Yeah.
So the vertex moves to 2a. Lines will be parallel to wherever we were. I mean, absolute function. So we have to sketch the absolute function, which will be kind of like this, right? So that becomes the absolute value of x minus 2a. Where a is a positive, so therefore we went right. So a is positive, we are moving in the right side. Show the coordinates of the point where the graph meets the axis. That means 1, where it meets the x-axis.
And y-axis.
And the y-axis. So at x-axis, it meets always at 2a is the x value, y value is obviously 0. And on this, we have to find, that means we have a value where x equals to 0, right? So, so basically, we'll say x equals to 0. That means what? Y equals to absolute value minus 2a. which is 2a, right?
Right.
So this point here is 2, and that matches with the gradient, right? The gradient is 1, -1 or 1 on either side.
All right.
So,
Yeah.
so that is how you're going to do part A. Is that clear to you?
Yeah.
So we have got the condition. Using algebra, solve x in terms of A, this particular equation, right? Let's do this part now quickly. The
So y
question
equals
is,
a third x.
yeah.
So because it's not absolute function, it can go into the negative section, just a linear.
Yeah.
Yeah,
Absolute value equals to 1/3 of x. Now, since it is an absolute value, as you know, it will be a function like this, and that is linear 1/3 of x. It has already moved right to some units. So what do you expect?
So a third x, that's less than 1. So it should intersect the absolute function twice.
Correct. Because see,
Because it's
if you see the
less
gradient, you're right. Gradient is 1 here. 1/3 means it's more like this. Do you see that?
Yeah.
So therefore, you are expecting 2 points where it is going to intersect, right? So the
Right.
important thing here is to take care of the gradient, right? So that will help you to visualize your solution. So gradient for this is what? Let me write m1 is equal to 1 on this side, and here m2 is 1/3, correct? So it's less steeper. So it's going to cut the axis, both of them at a point. So two points of intersection, correct? So that is what you see. In absolute value terms, what we could say is that inside, if I get -1/3, see, we see both x values are positive, right? Do you see where?
Oh, yeah.
Intersects when x is greater than equal to 0, right? So both x values are positive. Is it okay?
Yeah.
So that means this should be equal to absolute value of minus or plus. Do you see that? So simple equation to solve in this particular case is x is greater than equal to 0, where x minus 2a can be equal to either +1/3 x or x minus 2a equals to -1/3 x. You get the idea. So those two equations are going to give you the two solutions. Clear?
Right. Yeah.
So in terms of A, we can always bring this to one side, and then so you say something like,
sorry,
okay, that's fine.
I think that's me. Yeah.
So now we have to find the value of x in terms of A. So let's bring this on the left side. So let me, can you reduce your screen so that we get more white space to work with?
Oh, yes.
Yeah, that is better. Yeah, now, yeah.
I know it's small, but I can't, there's no
because now we don't
between.
have to read the question, right? We just need to solve these two equations, correct?
Yeah, yeah.
So, okay. So we'll bring x to one side. So let me do this one first. So here it will be x plus 1/3 of x equals to 2a. Well, we could do plus and minus. And then this is 4/3x equals to 2a, and x is equals to 3/4 times 2a, which is 3/2a, right?
Oh, yeah.
So that is one of your answers. The other one, you solve the first equation, which is this one, right? So let me solve this in a different color. So when you bring minus on this side, I mean, this we solve, right? The next one is this. One is with positive, one is with negative. We'll do this one now. So we have x minus 2a minus 1/3 of x equals to 0. Combining these two terms, we get 3x minus x over 3 equals to 2a, taking it that side. 3x minus x is 2x, so correct?
Yeah.
2x equals to multiply that and divide, right? So 6a, x is equals to 3a. Correct?
Right.
So we get two different solutions, one as x equals to 3a and the other one as 3 by 2a, right? So let me
Yeah.
redo it cleanly here. Let me clear all this and redo it. Can you, Amy, please say the question once again? What was it? Absolute value of
Oh,
x minus 2a, right?
yeah.
Equals
So
1/3 of x, right?
yeah,
Yeah, now you
equals
can
1/3
reduce
of
this
x.
thing. Yeah, now you can reduce this. So that gives us two equations to be solved. Here is the summary of our solution. X minus 2a equals to 1/3 of x. And the other one which we are going to solve is x minus 2a equals to minus 1/3 of x. So in general, that is how you're going to solve, right? Now bringing this x plus 1/3 of x equals to 2a. Yes.
Sorry, sir. Just a quick thing. So I'm just a bit confused why you did plus and minus of the 1/3, because I thought the x minus 2a was in the modulus. So you do like piecewise of that function.
Yeah. So basically, yeah, you're right. So when you, what you do basically is you can do like this also. Yeah. What you do actually is x minus 2a, you write as a piecewise function, right?
Mm.
You say this is plus x minus 2a and minus x minus 2a within the interval when x is greater than equal to 2a, right? And when x is less than 2a, in that case, it is minus, correct? You do all
Yeah.
those things. But that is not required. I'm telling you a shortcut method to do this equation.
Oh.
And what I'm telling you is this. Let's go through it once again. It's very important to understand this part. When we had the equation x minus 2a, it really means that your graph is starting at 2a with the vertex at 2a, right?
Yeah.
And the gradient m is 1, right? On this
Yeah.
side, and of course, minus 1 on the other side. The other equation given to you is 1/3 of x. 1/3 of x can intersect only quadrant 1. Do you see that?
Yeah.
And the 2 points are these. Is it okay?
Yeah.
That's 1/3 of x. What we're trying to say when we solve x minus 2a equals to 1/3 of x, it really means that the value inside could be plus or minus 1/3 of x, correct?
Oh, the value inside. Oh, yeah,
The
yeah.
absolute function could be plus or minus 1/3 of x, then it is equal to 1/3 of x. Does it make sense to you?
Oh, yeah. Wait, so why do we never solve like that then? Why
I
do
don't
we
know.
always do that piecewise thing?
There is no need. That is what I'm
Yeah.
trying to say. What we do is we split the function into those two arms, right? And then
Oh,
individually solve two of them. Okay.
yeah.
What I'm trying to say here is very simple. Inside function, we are looking at plus or minus
Yeah.
1/3 of x, correct?
Yeah.
So I could straight away write the inside function as it is and make plus and minus the right hand
Oh.
side.
Yeah, because whether it's minus a third x inside or plus a third x, the value that you get at the end is a third x. So you might as
Yes,
well make that whatever's inside equal to plus or minus a third x.
got it.
Oh.
So do it like this. It is much faster. You do not have to redefine an absolute function.
Yeah.
You only understand the concept of absolute function to begin. It is a very simpler and much better approach. That's what I'm trying to say, right?
So you're so smart.
So we have two parts to it, right? We can say part 1 and part 2, where x minus 2 is 1/3 of x or minus 1/3 of x. Is that clear to you?
Yeah. Mm-hmm.
I want to write minus. Okay. Of course, we want to find the value of x, bring x on one side and solve for it. So x plus 1/3 of x is equal to 2a, and x minus will bring one side, so we'll bring this as minus. I'm bringing here this positive thing, and I'm keeping the left side as negative. So this will give us 3x minus x over 3 equals to 2a, and that will give us 3x plus x over 3 equals to 2a. Clear?
Yeah.
So this gives us 2x over 3 equals to 2a, and that gives us 4x over 3 equals to 2. Is that clear to you?
Yeah.
So here we get x is equals to 2 and 2 cancel, 3a, correct? And here we get x equals to, when you multiply and divide, 3 by 2. Is that clear? Just solve for x.
Yep.
So we get two answers for this immediately from here. One is x is equals to 3a, and the other one is 3 by 2a. Is this clear to you?
Yeah, very clear. Wow.
That is how
That
you...
was so quick. Yeah. Yeah, you're
You
right.
have
Just the
seen-
concept needs to be understood. You don't need to necessarily know the whole absolute function, everything, how to work it out.
Because, you know, the type of example which I'm going to share with you is, we'll have a quadratic equation, and within the quadratic equation, we'll have an absolute function. Now, if you start splitting the absolute function into
So
2
hard.
or 4,
Yeah.
you will end up with 8 equations to solve. How will you solve it? You cannot.
You can't, no. Oh, okay.
So
So only
this
if you use
technique-
your method, yeah, you can solve that quadratic one. Yeah, okay.
So this part is clear to you?
Yeah,
What
very
was the
clear.
other part of this question? Or did we solve everything?
I think there was just the last part
Okay.
C where it says on a separate diagram, sketch the graph of y equals a minus absolute function of x minus 2a, where a is a positive constant, and then show the coordinates of the points where the graph cuts the axes.
That you could do. So a is
Yeah.
a constant, and then you can do minus, make a table. I'll suggest make a table here, correct? That
Yeah.
will help, right?
That's
That
all right.
will help. And then you get it. Okay, so that's not a big deal. Okay, so let's share with you some other questions on absolute function, which you have.
All right. I had a random proof question. I don't know if you
Okay.
want to go to that or
Sure,
one more
sure.
of this.
Sure, sure.
Okay.
Random proof, let's do it.
Okay. Yeah, it's a bit of a different one with absolute functions.
Okay.
But
Can you please
yeah.
read the question?
Yeah. Are we doing part I? That's a bit of a random one. I think just part 2, right? Yeah.
We'll
Cool.
okay, we'll do part 2.
Yeah.
We are looking
So
into absolute function today. Yeah.
yeah. So given that x belongs to real numbers, the value of the absolute function of 3x minus 28 is greater than or equal to the value of x minus 9. State, giving a reason, if the above statement is always true, sometimes true, or never true.
Yeah, very interesting question. So let's look into both these functions. Let me first sketch the absolute value function. Is it okay?
Yeah.
Okay. So let's do it here. So when we say 3x minus 28, so let me write this function, what it really means. So we have y equals to absolute value of 3x minus 28. We could take 3 common, and that means we have x minus 9 point something, right? What is
Yeah.
9
9.3 recurring.
9 point, let's write 9.3.
Not a nice number. Yeah.
Yeah, not a nice number. Yeah. So as far as this function is concerned, it basically means I have, if you look at the inside function, let's look into inside function. Okay, I want a lighter ink, which is 3 times x minus 9.3. Straight line, right? So we can sketch this straight line, which has a gradient of, if I put x equals to 0, I get a gradient of minus this. Or you could say at x equals to 9.3, we get 0, right?
Yeah.
So there's an x-intercept here at 9.3. And the line is, when I put y equals to 0, let's say when I put y equals to 0, when will that be 0? X will be what?
28.
So 28 by 3, right?
Oh, do you mean the y-intercept?
Yeah, the y-intercept.
Won't it just be 28?
X equals to 0, yeah, 28, minus 28. So it'd be minus 28, right?
Oh, well, because it's absolute function.
No,
It'll just be
I'm drawing a line only, right? Minus 28. Is that clear?
Oh, I see. Yeah, yeah.
So when you want to draw, what I've drawn here is 3x minus 28. Is that clear to you?
Yeah.
Okay. So that is my line. So crossing through this. So we know the gradient of this line is m equals to 3. Is that okay?
Mm-hmm.
That is the gradient of this line. Now, when we talk about the absolute function, it really means what? It means that the right-hand side will remain same. However, the left-hand side will get reflected because of this vertex. And that becomes 28. Is that clear to you?
Yeah.
So this now becomes my absolute function, which is 3x minus 28. Clear?
Yeah.
Perfect. Now let's see the other function, which is, let me write in a different ink, x minus 9. So let's say y equals to x minus 9. X minus 9 really means that when y-intercept will be at 9, right?
Yeah.
X is 0 minus 9. So let's say somewhere here, right? And the gradient is 1. So here also, when I put y will be 0 at this, and when x is 0, we get minus 9. So y equals to minus, if y is 0 at x equals to 9. Well, this point will be very close to 9.3, right? And
Yeah.
so this line could be drawn like this. This line is x minus 9. Is that clear to you? Where the gradient m is 1. So this is not an exact drawing, but it clearly indicates that the green graph of absolute function is steeper than the red graph.
Yeah. Yeah.
That's the whole idea.
Yeah.
Now the question is, given x belongs to real numbers, the value of this is greater than or equal to the value of x minus 9. So you have to compare, right? From the graph, you can easily see that the line is above the absolute function in this interval. Do you see that?
Yeah, but only in that interval.
Yeah, but not always. So now the state giving a reason, if the above statement is always true, sometimes true, or never true.
So sometimes. Oh, okay.
Sometimes. That is how you could explain it. Is that okay?
Mm-hmm. So for that 2 marks, do I just draw this graph, or do I need to find those intercepts and say in the interval between this and this, it's only true?
Greater than.
Like that.
Yeah. You could do that. So what you could also do is, you are right. First, I have sketched the graph and I have shown that there's an interval where the line is having a higher value than the absolute function. And the second part, as you are saying correctly, is you could find these point of intersections, right? So let's find point of intersections and show it. Which are these 2 points? Graphically, I have already done. So we could have 3x minus 28 equals to x minus 9. That is one equation to be solved, correct? Mm-hmm. Which is on this side. On the other side, we are solving the equation minus 3x, minus of this means plus 28 equals to x minus 9. So you have to solve these 2 equations, correct?
Oh, right.
That second equation will give me second point. Is it okay?
Yeah.
And once you find these 2 points, A and B, let's say, then you'll say sometimes true, since between the interval A to B, it is not greater than equal to the line, correct?
Oh, yeah.
Okay. That's simple linear equation to be solved.
I was just quickly solving it.
Okay, solve it. Get the answer. Yes, that's correct.
So I got x is 9.25 and x is 9.5. So 9.25 will be that value before, left side. So then 9.5 right side.
9.25 on the left and 9.5 on the right. Correct.
So you would just say, between that interval, it is greater than, or no, sorry, the line is greater than or equal to the modulus, but not.
So this statement is only true if the interval is from minus infinity to 9.25, right? Are they including it? Greater than or equal to, so you include this point, correct?
Yeah.
Or from 9.5 to infinity.
Yeah.
Correct.
Clear. Okay. So that was a nice, because I haven't seen these proof questions within a modulus. That's why I was just asking.
Yeah. Nice.
All right. So yeah, that was kind of the questions that I had. I had one from school, but
We had been working with absolute value functions, which you call modulus functions.
right.
And in that, you are talking about some problems which involve quadratic equations and the linear equations. So you can share with me the questions which you have. You already shared some about which you really want me to solve. Could I have some questions? We can discuss that.
Yeah, I had a question from school today.
Mhm.
So it was the modulus of x squared minus 8x plus 12.
I will share the
E-
whiteboard and write down there, and then we will take up your questions, right?
All
So,
right,
okay,
okay.
can you please tell me once again, what is the question?
So the modulus of x squared minus 8x plus 12 equals to the modulus of x plus 4.
Perfect. So we have a quadratic equation and the linear function. So few points are very important to take care. If you split the quadratic function absolute value, it splits into three parts, right? So basically, if you want to sketch this, how will it look like? Let me sketch and show you.
Okay.
First, let's factor this part. So which is what? X 12 means 6 and 2, right? So minus 6 times minus 2. Well, that is equals to x plus 4. Now, if I want to sketch this, it will look like, so absolute value. First, I will draw, so 2 and 6 are two zeros for the quadratic function. Correct. So this part which I've drawn, actually, because the absolute function will become like this, clear?
Right.
Now, what is the value? What is the maximum here? This is a very critical point. Let's calculate this. Maximum will be, this is at 2, this is at 6. So maximum will be at 4, correct?
4.
Midway.
Yeah.
So if I substitute 4 here, what do I get?
Minus 2 times minus 2,
4 minus 6.
which
Yeah,
is
yeah.
4.
Absolute value. 4 minus 2. Which is minus 2
Minus
times
4.
minus plus 2, absolute value. So it is 4, right? Okay. So we get that part. So we have one function there. The second one is x plus 4. Now, x plus 4 means the y-intercept being 4. That means this is the y-intercept for the other one. And the gradient is 1, right?
Yeah.
So gradient is 1. So it is, as compared to this, it is not all that steep. So I'll draw like this. So this line is strictly speaking, we are talking about absolute function that gets reflected, right?
Yeah.
Now, from here, what do you notice? How many solutions do you have for this particular equation? Tell me.
So would it be 2 because it intersects the graph twice?
Only two solutions. Second,
Yeah.
where are these solutions? They are in this interval, right? Less than 2 and greater than 6. Is that okay?
Oh, yeah. That's really important. Yeah.
So we have figured out that they are in this particular interval. And as far as the linear equation is concerned, it is on the right side, correct? So we
Right.
will define our function in these intervals. So as far as x plus 4 is concerned, let me write here. As far as x plus 4 is concerned, absolute value will be equals to x plus 4, right? Because we're looking for absolute value of x plus 4 when x is greater than equal to minus 4. Is it okay? On the right side of this. On the right side of this, correct? So it is absolute value. And as far as the quadratic function is concerned, we are looking into the interval when the original graph is positive. That means it will remain positive, right? So it'll be x squared minus 8x plus 12. Is that clear?
Yeah.
So this part is positive, means I'll write it again here, x squared minus 8x plus 12. So the equation to be solved is this equation. Is that clear to you?
Yeah.
Let's bring the terms together and solve. X squared minus 8x minus x plus 12 minus 4 equals to 0. So that means x squared minus 7x plus 8 equals to 0. Well,
Minus,
can be
wait, 9x.
Hmm?
Minus 8 minus 1. Minus 8x minus x minus 9.
Minus 9. You're right.
Yeah.
Minus 8x minus 9. Correct. Now, the factors will be what? 8 is like?
Minus
8 and 1. 8 and 1,
minus
right?
1.
X minus 8 times x minus 1 equals to 0. So that gives you x equals to 8 and, 8 and x equals to 1. Clear?
Yeah.
So that means this point is 1 and this point is 8.
8.
Does it make sense to you?
Yeah.
Simple.
There were so many things in this question.
Can you summarize your learnings from this few steps which I did?
Yeah, definitely. Okay, so this is the part that I really struggled with. So thanks for clarifying that. So the first part was this whole intersection business. So it's all about the gradient. So in this case, we know that the quadratic curve is like steeper than the line. So it's obviously the graph is just showing at some point that it's ending, but obviously it's going to be endless. It's going to keep going up. So the linear line x plus 4 will intersect at the 2 points, but only in quadrant 1 because it's a modulus function, the linear one. The negative part gets flipped, so there's no intersections in quadrant 2.
Correct.
So you can see that intersects twice. But my question was, you see the part that's been flipped. I didn't know whether it intersected with that or even scraped the curve like a tangent. Mm-hmm. So to figure that part out, you have to find the y value. And you simply do that by substituting x equals 4, which we found from the midpoints from factorizing, and then subbed it into the quadratic equation and got the value as 4. So we know the linear intersection of that line starts at 4, so it can't touch the curve. Even if the graph is not drawn to scale, you can see that it won't touch that part. So that was a key thing. Then the next part was, after seeing where it intersects, it's all about looking at the interval where it's between. So as you can see on the left-hand side of the quadratic, it's everything that is to the left. So everything to the left, which is x being less than or equal to 2, and then everything to the right is x being greater than or equal to 6. So because those two intervals come in the same equation of x squared minus 8x plus 12, the positive value, we just do one simple step by taking that equaling to x plus 4. You don't have to do the negative because that interval is between 2 and 6, which the linear line hasn't touched. So you wouldn't do that. Perfect. And then we just solved. Yeah.
Very good. Now, Amy, that brings us to another interesting question. If I change my question, right? If I make this as absolute value of x minus 4, let me change the line, that pink line which is going there. Yeah. So if I make it like absolute value of x minus 4, let us say, right? So in that case, the graph will be kind of like what? It will like go like this, right? I mean, yeah. You understand? So we have 4 solutions.
Right. So then you've got 1, 2 on the quadratic, and then 2 on the...
Yeah. So that becomes scenarios different, right? This is when absolute value of x minus 4, right? Then you can see that now we have 4 solutions. Does it make sense to you? In that case, you have to solve all the 4 equations.
Right.
In different intervals.
Yeah.
So you'll choose one interval which is from here to here. Do you see that part? So there are 4 different intervals to work on. So that becomes a very tricky question.
Oh, you can't just say that those two intersect between 2 and 6 and then
because these are different equations to work. So one interval, because now one interval is this equation within, so we have to do minus infinity to 2, one interval, and get that point. And then you have to work from 2 to 4, get the next point, and then from 4 to 6, get the third point, and then 6 to 8, then get the fourth.
Oh, and the only reason that for the previous question, when it was x plus 4, we just did the one equation, is it because it was infinity like to 2 and before it wasn't between an interval, it was because of the infinity part? Oh, right. Okay.
So whenever you have a quadratic equation with a linear equation, it is
Yeah.
worthwhile to sketch and see where are the results and then
Oh,
solve relevant equations. Otherwise, if you just want to do blindly, you're welcome.
no.
You have to do four equations in 4 different intervals, and then
Right.
find their solutions and figure out which ones are relevant, which ones are extraneous. You get the idea.
Yeah. Yeah, definitely. Okay. So yeah, it can get quite complicated. I didn't realize. Yeah.
It gets very complicated, very complicated. Now, this brings me to another very interesting question where I have absolute function within an absolute function, right? And it's also quadratic in nature. So let me share that question with you.
The ultimate question.
Here, very similar to what you gave me. So it is absolute value of x squared minus 4 absolute value of x plus 3 equals to 3. On my YouTube channel, you can check the solution of this, but we will discuss how do we solve this, Amy?
Yeah. Okay.
So, Amy, let us discuss how do we solve this equation? How will you solve? What is your suggestion?
So obviously we have to sketch.
Okay. Okay.
But there's an absolute within an absolute. So I'm finding issues piecewise. No, I don't know. I don't know. Bit tricky.
Yes. So because
can you factorize?
You could factorize, yes. You could.
But with the absolute, would that change how I factorize it?
So you could have both positive and negative x, and then you can figure it out, right?
Because minus 3 minus 1.
Let us say you're talking about x, which is absolute value of x, which is you're looking at x greater than equal to 0, or when x is less than 0. So it is x or minus x, correct? So within those two intervals, what you get here is that here your equation is x squared minus 4x plus 3. But when I do x minus side, that minus becomes negative.
Plus.
So I get plus equals to 3. And on the other side, I leave it as such. And then we have this equals to 3, correct? So what we are doing here is we're working on x, which is less than 0. And here we are working on x, which is greater than 0. So we get two quadratic equations like this, correct?
Yeah.
On either side. And then you can solve it. There is definitely one way of doing it, right? Another way, which I'll suggest you now, you know what are even functions and what are odd functions?
Mm-hmm. Yeah, when you say it's like symmetric about the y-axis.
Yes, symmetric about y-axis. So we know that f of x is given to us as x squared minus 4 absolute value of x plus 3, right? So what is f of minus x? It is minus x squared minus 4 absolute value of minus x absolute value plus 3, which is the same as x, right?
Yeah. So 4x.
It is same as f of x, correct? So it is an even function. So when I say it is an even function, that means if I solve only one side, I'm okay because the solution is symmetric, correct?
Right.
So that, and obviously when you look at this function, right, we know x squared is even, right? We know 3 is even, and we know absolute is also even. So therefore, this is an even function. I just justified to you why it is an even function, correct? Because it gives me the same value, right? For f of minus x. But that helps me to solve only one side of the equation. I do not have to solve the other side.
No. Oh, yeah, so it saves you time. Wait, so just a quick thing before you move on. So if it was an odd function, would the result that you get be minus f of x?
Yes.
Okay, cool.
So basically now, we are only solving for x greater than 0, but now our function is x squared minus 4x plus 3 equals to 3. You get the idea?
Yeah.
Absolute value of this. I've already opened up this part of this question. You understand? Otherwise, it was very complicated. Okay.
Oh, right. Yeah.
Let's try to look at this particular portion, which is what? Can you factor this? 3 times 1 is 4, correct?
X minus 1 and x minus 3.
absolute value equals to 3. Now again, as we did in the first case, let us try to graph this also.
Okay.
So let's graph it. I'm purposely, let's use this side to graph. So we are only looking for x greater than. So on this side, x minus 3 and 3 will be what? So we have a graph which is kind of right.
So how come you chose? Wait, if it's an even function, how come you chose that equation?
Okay, the other half will be like this. You understand? Actually, the graph is this. This is the graph of this function. Do you understand?
Oh, because x is less than 0.
Yeah, we are only working on one side of the graph.
So how did you know it was on the right-hand side? We figured out it was an even function, but what does that mean?
We can do either right-hand side or on the left-hand side. It is our wish.
Oh, so you chose right just because.
Yeah, you choose right.
Oh,
we know the answer is symmetric. So do you see, by doing this calculation of even function, we avoided working on this part altogether.
Oh.
We're working on the right-hand side of this. We are only working quadrant 1.
Yeah, and then we can use our results and just switch it to quadrant 2 because it's symmetric.
Minus of that. So x values will be plus and minus of whatever we get now. You get the idea.
Oh. Yeah, so that's so important, knowing this even and odd. Okay.
So whenever you have quadratic equations involved with linear or whatever, it is important to visualize the solutions and then do it. You understand?
Oh, right. Yeah, yeah.
Now we'll look into this
so
part
important.
of the graph. We are saying value is 3, right? So let us find the maximum value of this graph. So a maximum will be at 2, correct?
Yeah.
So at 2,
sub in 2.
2 minus 1 times 2 minus 3, which is 1, right?
Yeah. So maximum value is, so 2, 1. Yeah.
1. But we are looking for 3, right?
Yeah.
So that means I do not have to look into the negative part which was flipped, right? I'm only looking into the positive part which was not flipped.
Right, right.
So
okay.
I'm only solving x minus 1 times x minus 3 equals to 3. Does it make sense to you?
Yeah.
So I avoided another 2 equations. You get the idea? That ways I've simplified this question from working on so many 6 equations to just 1 equation. By reasoning and saving my time because of good understanding of absolute functions.
Yeah, yeah.
Correct?
Yeah, that's so important. Oh my God. So you like saved the whole calculation with that one just by knowing it's an even function. Then you did another one just by finding where the maximum was and seeing that it didn't intersect the flip part.
Correct.
Equal into 3. Oh, wow. Okay.
Now we are left with,
you just do the reverse.
So basically, we can get back to our original equation because when you expand, you get this, right? X squared minus 4x plus 3 and bring 3 this side, right? Minus 3 equals to 0. Does it make sense?
Yeah.
So that means x squared minus 4x equals to 0. X minus 4 equals to 0. So we have 2 solutions. One is x equals to 0 and x equals to 4.
Yeah.
You get the idea? So what the answer will be what? Plus and minus. You get the
plus
answer?
Plus and minus 4.
So answer will be 0 and plus and minus 4. Because it's symmetric.
Yes, yeah.
So this point happens to be 4 and that is actually this point common. So obviously when x is 0, it is 3. You can see it, right?
Oh, wow.
Y-intercept 3 and 3. So it makes sense, right?
Yeah.
How easily I've done this solution just by understanding the concept.
So like when other people around you are like scribbling away, just writing formula and doing the method, if you slow down, just think logically what actual calculations you need to do, then you end up getting the right answer in quicker time when it might not look like it because everyone else is like scribbling away doing what's supposed to be done. So yeah, understood.
And if you really sketch this graph, obviously at x equals to 0, I'll find that this point is 3, right?
Yeah.
I already have a solution. At 0, we have 3.
Oh, Yeah.
You get the
So
idea?
that's already done by sketching it, which was done ages ago, right? So you just have to find the other two.
And
Got it.
so, and we knew this is the line. The other point is what? Calculate 4 minus 4 here. Done.
Which makes sense. Oh, okay. And
Such
because
a
of the
difficult
symmetry.
question. Such a difficult question. And solved so easily because of
Yeah.
the concept.
All right.
You get the
Okay.
idea?
Yeah. So no amount of memorization of the method can get you this. It has to actually understanding concepts.
Yes.
Okay.
So can you
Yeah. Thank you
summarize
so
our
much.
learning today? Then we will end the
Yeah.
class, Amy.
So yeah, many things. Many things. so many that I actually can't. It's like blown my mind because I never thought of answering the modulus questions like this in this
Your
way. That's
video,
why.
Amy, your video, yeah, no, it's okay. Yeah.
Oh, sorry. I'm quite surprised because I haven't actually answered the questions like this. So a couple of things was in terms of sketching, it's all about, especially with these modulus equations, especially involving quadratics and then equaling a linear or whatever. It's about so factorizing and always drawing like a sketch. I don't understand how important this is. It doesn't have to be to scale or anything. It just gives you an idea of what you're looking for, where the intersects are, and it's like super, super important. So when we first started with the question I had from school, that was fairly straightforward compared to the one that you just gave, but I thought that was actually quite hard.
Yeah,
So it was. Yeah. So it was all about, the issue with me was that I wasn't looking at the intervals. So when it intersected, I didn't look at it, x being like less than or equal to 2 and then just seeing that side of it and then x being greater than 6. So because you told me that and then told me about the intervals, I only had to do one equation. So I didn't have to use the equation here because the graph didn't intersect with that part, or it wasn't a tangent, it didn't even cross below it, so I didn't get 4 solutions. It was just the 2 from that one step. So that part was really clear now because I've understood actually how to like draw the graph, and also about where the gradient is in terms of steepness. So if the quadratic is more steep, it won't intersect like just once, it will intersect twice. So yeah, you can figure that out. So the one with the one that Sir just gave was an absolute function within an absolute function. So that part was, so when you look at it straight, it was actually like a bit threatening because I've never seen it before. But then you simplified it like really like well so that I could actually understand it. So I think the main part was just kind of proving that the equation given was either an odd function or an even function. And when we calculated it and subbed in minus x, we got that it was basically exactly the same as f of x. So the function ended up being an even, which means it's symmetrical about the y-axis, which is so helpful, meaning that we just had to do one calculation because whatever answer we got, we could just do the reflection of the minus, invert the signs, and then you can get the other values. So that was super important. Then when we sketched the graph, like I said, immediately after you sketched it, you could see that the point at 0, we got 3, which was the line given. So already one solution was done. We just had to calculate the other 2 by drawing a line and again seeing that when we found the turning point, what was it called? The y value of that turning point, we got it as 1. So because the graph, the linear line they were asking for was y equals to 3, it didn't intersect with that line. So again, we just had to deal with the one equation and then solved. So yeah, that was, you made a hard question look very easy. Yes. So yeah, thank you.
Critical things, let me summarize once again. When you sketch all the intercepts, x-intercepts and the y-intercepts, so that you have clear idea where your graph lies. Second, whenever a parabola is involved, also find the local maximum or local minimum value, whatever the scenario is. So in case of absolute function, obviously the local minimum will be 0, but the local maximum could be that turning path, which we found 4 in one example, which was x plus 4 will go higher than that. So we need not even worry about that inverted part of parabola, correct?
Yeah.
So that avoids that negative part of quadratic equations to be involved in the solution.
Yeah.
So it's a simple quadratic equation to
the
linear equation solution rather than the absolute value, right? It becomes kind of same. Do you understand?
Right.
So this is what. And in the second example, which I took, once we have an equation ax squared plus bx plus c, if I make x as an absolute function, it will always be an even function. You get it? So there, if you see that you have absolute value. It means it's an even function, as we did. We'll only solve for quadrant 1, correct? And then follow the procedure which we used in your first example.
Yeah,
That is
same
sketching
thing.
nicely, but reporting solutions which involve reflection also on the y-axis.
Don't forget the reflection, because you ignored that as a method. You have to just remember it, the last step, that you do the reflection for that.
Correct.
So yeah, super important.
So
so many skills learned. So.
Yeah. I've seen these type of questions in many competitive exams. Actually, if you know the strategy now, you can easily solve these questions in no time and get full marks. That's the
All
idea.
right. Yes. All right. Thank you so much, sir.
Thanks.
That was
then.
super helpful.
Yeah.
Thank you,
See you
sir.
soon. Bye.
I'll see you soon. Bye, sir.